Alright, I'm going to be attempting to do problem 9, or chapter 9, problem 67. This involves a large wheel drum that is pulling a rope over a massless pulley. I'm not going to be able to draw this all that well probably, but it looks something like this. Where there's a pulley up here about which this rope kind of hangs down and then is pulling up this large mass. Hope that's seen okay. It describes that this weight has a mass of mg, and it has a tension up. And it tells us that this pulley up here is actually frictionless and massless. And so what does that tell us? Well, it tells us that if it has really no mass, then there's no moment of inertia up for that particular pulley, which is very different from the problem in your book where there is a pulley that's rotating that has some mass and has some moment of inertia associated with it. But because this is massless, it means that the tension here and the tension here is equal. The tension in this rope and the tension in this rope are equal in magnitude, at least, to one another. Again, that's also different than the problem in your book. One of the problems in your textbook asks a question about this. You have, maybe it's on a flat surface, but it's the case where you have some block like this, and there's some other block down here. And in that case, the tension up on the rope is not necessarily equal to the tension here. When the situation presents itself where we have a pulley with a specific moment of inertia, then the tension up is something different. So the tension here, we end up with this something like T1 or T2, and this one is called T1. Very similar to the example laid out in your textbook, where it shows that the tension here is different than the tension here because some of the tension that is pulling down is actually causing that pulley to change its angular velocity. Right? It's resulting in some change in angular velocity. So not all of that tension is going to pull the rope on the other side. Coming back to this problem 967, it describes the mass of this block as being 2,000 kilograms, and it tells us that it has an upward velocity that is equal to 8 centimeters per second. By a steel cable that passes over a massless pulley to a motor-driven winch. The radius of the winch is 30 centimeters. So it tells us this is 30 centimeters. And asks, what is the tension in the cable? Excellent. All right. Well, we know that we can write a Newton's second law equation for this object over on this side, which is simply equal the sum of the forces, or the net force, is equal to the mass times acceleration. All right. So we know that the acceleration for this case is actually equal to 0 because it's moving at some constant velocity. So the change in velocity is 0. There is no change. So the acceleration is 0. But the net forces then tells us that the tension is going to be equal to, the tension, which if we choose up to be positive, tension minus the gravitational pull downward, minus mg, is going to be equal to 0. So the tension in the rope is equal to mg. All right, that's part A. What is the torque? What torque does the cable exert on the winch drum? All right, that's also a very, very good question. So the cable is, the winch drum is pulling on the cable in this direction, right? So the torque is pulling this way, so that is going to pull on the winch drum in that same direction, right, along this rope. So the torque is going to be equal to the lever arm times the force acting on it. That force is at a 90-degree angle to the radius. And so when we go to figure out the magnitude of this, we will determine that the angle is pi over 2, or 90 degrees. So this sine of pi over 2 is 1. And so we can determine that the tension here, or that the torque rather, is equal to the tension, which is mg times the radius, right? So radius times the mass times the gravity. And we can plug in these various numbers here. Obviously this was 2,000 kilograms. If we take gravity to be about 10, this would be about 20,000 newtons, right? 20 times 10 to the third newtons. For the tension, we have, again, that 20,000 newtons times 30 centimeters, which is 0.3 meters. So what would that be? That would give us something like, well, we're just multiplying these together, right? This isn't that difficult. It would be 6 times 10 to the third Newton meters, right? That's the torque acting on that winch. All right, hope that's clear. I'm going to take a brief pause and start up another video.